Hello, everybody. This is another edition of Near Workshops, and today we have one of the most teams I'm proud of in the Near ecosystem that's really putting work in the privacy measure with Hideyour.cash. They're the Hackachain team. And yeah, I don't want to spoil too much, so let's just let them take it away.
Want to start, Rafa?
Yeah, sure. So nice to meet you all, guys who are watching us. Just like Code said, we are Hackachain. Hideyour.cash is one of our adventures here. And well, basically, Hideyour.cash is a security audit and software development company specialized on NIR protocol. And we have been developing some tools for NIR, some DApps, and Hideyour.cash is, well, one of our kind kids right now that we have been taking care. It's currently on testnet, and we are going to present it for everyone today. Talk about about the tech, about the use case, about the history about Hideyour.cash, how did we decided to start using and building it, and well, let's do this. Go ahead, John.
Yeah, for sure. So nice to meet you all, guys. My name is João. I'm the CTO for Hackachain, and this is one of the products that I envisioned myself. So essentially, for those who don't know what this is a kind of a NIR version of MinorityProgrammers. So we're kind of building the whole mixer approach into NIR, but with a twist. We know NIR is a network that's focused on real use cases, on integrating with like real financial system and like firms and actual people that are not blockchain native. And one of the main demands in there is to actually have like compliance and a tool that can be guaranteed to be used only by legitimate people, not by criminals. And this is the idea here. We essentially built a version of Hideyour.cash that is hacker proof and essentially money laundering proof. So we can have all the privacy without having the criminals. And this is kind of what the app is. But before I explain what it is, I think it's important to understand the problem that we have in blockchain. Because even Shot himself told me before we started the recording that a lot of people were actually asking, why do I need a mixer? I'm not a criminal. I'm not doing anything wrong. Why do I need privacy? And this is a very interesting point of view. It's a very common one, especially when people don't understand how the blockchain works in detail. So essentially, the word blockchain, public ledgers, what it means is we have a complete history of all transactions that ever happened on NIR, and it's the same thing for Ethereum, it's the same thing for Bitcoin. So we have an entire ledger of all transactions since the inception of the blockchain up until this point, recorded, and absolutely anyone can read it at any time. It's public. That's very good for verification and allows us to have a lot of security in terms of consensus and in terms of decentralization. But on the other hand, anyone can actually go to this history and learn a lot of things about each of the accounts in there just by looking at who, when, and the values that they transacted in the blockchain, which contracts they called, and which interactions they made. So essentially, when you talk about NIR, we have like accounts that have names. So we have a name system. My account, for example, is joaovega.nir, Rafa's is rafael.nir. So it's very easy to understand, to know who you are based on your account. And once you get to know, once you link a real person to an account, you can learn a lot of information about that person from the entire blockchain history. For instance, let's say Hackachain pays our wages in crypto, which it does. When we do so, we automatically link our accounts to Hackachain. So anyone that doesn't know us can just look at our accounts and learn that we work for Hackachain. That means we are developers for them, probably. That can make us like credible targets for kidnapping or for robbery based on criminal activity, or it can help someone gain intelligence on us by following our personal information and going to our social media and etc. And that problem really gets augmented when we think about crypto in the long term. So we're all here because we believe in a crypto future. We believe that crypto will, at least to some extent, be used by almost anyone in their daily transactions, in their value stores, and everything that they financial and non-financial in their lives. And if that happens, this setup is simply terrible because we cannot have a blockchain that's fully public that shows everything you have ever done for the entire history, if that's like where you keep all your money. People are gonna know if you're spending money at the doctor, if people depend on you for a living, who you work for, what you spend your money with. So this is like a spy's dream. It's very easy to get all of that information. Up until now, this information is protected by law in most democratic countries. So only banks can access it under like under law enforcement request. And in some countries, like the United States, like Brazil, this information can only be accessed if you have like a judicial order. So the current system, the traditional system, is more private than blockchain already is, and that's why we can't simply say that mixers are for criminals. Mixers are actually a very needed technology for everyone if you ever hope to achieve like a mainstream usage of crypto with the current tech that we have. It's impossible to think of Near, Ethereum, Solana, or any other chain being publicly used for real life stuff by normal people without having this kind of tools. So this is kind of the introduction of why this is necessary and why we're building it all. Do you want to add anything, Rafa, before we go to the tech?
No, go ahead. I have some noise in the background. Okay.
No problem. Awesome. So essentially, I'm going to show you guys the app. But first, I'd like to show a little presentation that we have here, just to touch on a couple of points. Essentially, so all transactions are public. These are symbol, pretty cool. And there are a lot of solutions on the market. So Tornado.cash is one that's working on Ethereum. Monero and Zcash are blockchains layer ones by themselves. So there are a lot of people thinking about this issue. And there are a lot of like solutions that people have devised for them. So this is kind of a diagram we drew representing which kind of solutions we have for privacy. So like in this axis here, we measure how private the solution is, and in this axis, how compliant it is with law enforcement. So to which extent it blocks illicit finance. And currently, as we were talking about, like normal blockchains, they are not very private. They have like pseudo-anonymous accounts. So your account is a hash or a name that you choose in the case of Near, and no one knows that this account belongs to you. But once someone links your account to your physical person, they can learn about a lot of information about you. So it's not very private. Those solutions, Monero, Zcash, Tornado.cash, they all are very private in that regard, but they do absolutely nothing to reduce illicit finance. Neither of those do, because they don't evaluate who uses them. They are simply tech tools that allow people to mix funds without any kind of regard for illicit finance or not. And when we look at banks and the traditional financial system, at least in the free world, it's considered very private because only government and essentially under some very certain conditions can access the information. And they are very interested in reducing illicit finance, so they are up here in the schema. The problem is that they are centralized. So it's essentially what you're trying to do is you're trying to be here, like next to the banks, but being a decentralized solution that is very private and that is also working to reduce illicit finance. And this is obviously like a very big market. And ever since the Tornado.cash fiasco in the early months of the year, a lot of centralized exchanges and other centralized crypto apps have been blocking accounts that interact with those privacy apps. So it's very essential that you have a solution that can be accepted by those centralized apps and that can also provide privacy to everyone. I'll share the presentation with you guys later, so I'm not going to be reading it, but just getting over the main points here. Just they go for Tornado.cash. We analyze transactions only for well-intended users. This is how we're doing. And this is kind of the stack we're using. So we're basically using ZK snarks combined with blockchain analytics. So what this means is we have an on-chain ZK snark schema that allows us to verify proofs and to actually do all of the privacy engineering. But at the same time, we have an analytics engine running off-chain that is calculating security scores for accounts. So they're calculating probabilities that they're involved in illicit finance. And if they ever reach a threshold, they're not allowed to transact within the app. This is basically how the app works. And it uses a little bit of game theory too, as I will explain. So essentially, what we're aiming to build is a mixer that can work with Near or any NEP 141 token, no malicious user, and you want to integrate with other dApps natively. So integrate with wallets, exchanges, and etc., so that you can like have privacy by default. That means not having to go into this website here to be private. All of this schema will be automatically like embedded into other applications so that you can be private without even having to worry about. Which is kind of what we have with this little block here that you see today in the internet, HTTPS. It's a very strong cryptographic protocol, and no one knows how it works, but everyone knows they are safe because it's working on the background here. We kind of want to have the same experience on blockchain. So this is, I already explained this. So yeah, actually it's interesting. So what is a mixer? So a mixer essentially is a place we send our money to. So in the current system, whenever one person sends money to another person, that transaction is recorded into the ledger and is there for everyone to see forever. When we talk about Hideyour.cash, essentially we have a central contract, so the Hideyour.cash contract, and people send money to Hideyour.cash and generate like a secret key called a note when they deposit this money. And by using this note, like this code, they can send the code to someone else, and that person can withdraw from the contract. And all that the ledger stores is that these people deposited to Hideyour.cash and these people withdrew. But it never, you cannot learn who sent the money in and who extracted the money that person sent in, and that's the magic. So if a lot of people transacting, a lot of people send money to Hideyour.cash, a lot of people take it out, and you can never know who send the money to who in the end, like if you actually look into the full transaction. And that's how the magic happens. So it needs to have a little volume. It needs to have a lot of people transacting, but once it happens, it's essentially impossible to localize who sent the money to who in the first place. Well, so this is all more of an in-depth tech schema that I'll show you guys later. But how do we prevent bad actors? And this is kind of one of the more important things is we work with a allow list / block list concept. So essentially, you have to get pre-authorized to interact with the protocol. That means your account has to be vetted. And in case you have been involved in any suspicious activities, you're going to be blocklisted by one of our bots that is constantly like looking into the Hideyour.cash pool and analyzing all the addresses that interacted with it. In case anyone's blacklisted, the funds are freezed. So let's say that I stole money from a smart contract. I'm a hacker. I stole from Ref Finance $50 million. If I deposit this money into Hideyour.cash, it's going to be frozen by the block list. So I'm not going to be able to withdraw this money because the protocol identified that I was the initiator of a hacking attack. And the interesting thing here is that even if you do a lot of engineering, so let's say I steal from an account and I send it to another account and do like a whole ping pong of accounts, like send it over to 50 accounts and then to Hideyour.cash, even in that scenario, we can identify that the money was provenient from crime and freeze the funds automatically using the contract logic. And this logic comes from a partner today. So essentially what you have in the MVP is a partnership with Happy.one. They are a security protocol working on here. They pull data from a lot of analytics firms, such as let me get I forget the name right now. It's, you remember the name, Rafa? But they have a lot of different
Chainalysis
providers here.
Is one of them.
Yeah, they have Chainalysis, they have Ellipsis, they have a lot of the main firms. So they essentially they're pushing this data to the blockchain, and they're able to read it from our contract to actually fetch malicious addresses. So this is how it works. And if you want to look at this in practice, this is how the app works essentially. So we connect our wallets. Let me get an example here. I'm choosing Near wallet right now, but I could use Meteor or any different one. Let's take one of my trillions of testnet accounts here. So essentially, I just logged in. I have to get allowed in the allow list. So I just click here. And so you have to apply to the allow list. Essentially, this is mocked right now. So this functionality is
It's token 2.
I'm sorry?
I think you use the wrong account. It's token 2.
Okay. Sorry, guys. Info token 2. So essentially, there's a transaction here to authorize. So we are asking for authorization. So just authorize myself. And right now I can deposit money into the contract. So right now it only supports 10 year as it's a tested version and only supports near, but this is going to be generalized later. So we're going to be able to deposit any amount of near or any other NEP 141 token and use it into the protocol. So we deposit, it generates our code. So this code is very important. This is a cryptographic code that allows us to withdraw the money later. So whoever has this code is able to withdraw the money regardless of the account that they use. So this is essentially a node representing all the money. So we should save this into some kind of safe place. I'm just going to store it in a Word document for now, but this should be safely stored. You can actually send this to people. So if you want to pay someone, you can just send them this code and they can use it to withdraw the cash. So let's send the deposit. The deposit when we deposit 10 years into the contract, it sends this entire code over to the smart contract, and it's going to be using this to withdraw it later. So just hit approve. And right now what happens is the money is not in my account anymore. It is in Hideyour.cash's contract account. And if during the next hours, my account is discovered to have been involved in any kind of illicit activity, it's going to be removed from the allow list and I'm not going to be able to get back. If I'm ever removed from the allow list, neither my account nor any other account is going to be able to withdraw the funds. So let's just get another account here. We'll use this. I think this one doesn't have any funds. Let's get another one. Maybe this one. So if my account is involved in any illicit activity, then it's not going to be able to withdraw the money anymore. It's going to be locked into the protocol until someone goes to the DAO and presents the case and shows that they're in fact illicit, or if they cannot prove it, it's going to be locked in there forever. And that's where game theory comes into play, because no one that actually is doing any criminal activity is going to risk depositing their money into Hideyour.cash to try to get it off. Because if they ever deposit it, there's the risk that the money will get locked. So it's not interesting for them to try to use it. And that's what gives the system its security. If anyone ever tries to do so, they either have to be fast or deposit the money and withdraw it really fast so that the bots can't fetch the transaction, or the fund are going to get blocked. And if you're talking about privacy, if you just deposit and withdraw like really quickly, this doesn't really make your transaction private, because it's very easy to analyze the ledger and see that someone deposited like $10 million and someone withdrew $10 million like a second later. It's very easy to know where the money came from and where it went to. So this is where game theory comes in. So if I want to withdraw, I just come to withdraw and I have to paste the hash of the deposit here. So essentially the value I just copied from the deposit screen. Let me get it back here. And they also need the recipient address. So it's going to be contract deployed.desert. And the thing here is this transaction is not going to be sent to the blockchain by itself. So you're not going to be the one that sends the transaction. What's going to happen is you have a system of relayers. So these are like separate people that are running software. We send this code to them in the format of a ZK proof. And when we do so, they pay the gas for the transaction and send it to the blockchain. What this means is I can actually send funds to a new account that doesn't have any near without having to reveal who that account belongs to. Because if I have to like send near to a new account so that they can withdraw the tokens, what happens is that people see who sent the initial near. If you use a centralized exchange, everyone's going to be able to figure out that someone has an account in there that seeded the account. And if you use like another wallet, you're going to simply link those two wallets. So this is a way to not have this done. So you saw that it takes a while to create this ZK snark proof. So it's not instantaneous because this requires a lot of mathematical operations that we're doing in your computer. But this is an entirely local operation, so no internet is used here. This proof is not shared with anyone. All that we share into the network is a proof statement, and the proof does not reveal the initial code. So even if I send this proof to someone that is malicious and tries to steal my funds, they can't use it to steal my funds because the proof that you generated is only valid if you send the funds to the account that you inputted here. So just confirm it. And that's it. After you confirm it, the funds are going to be dropped into your account. It's just that withdrawal send. It says send instead of send. That's a typo. But it's as simple as that. That's how the app works. You deposit money with an account, and then you send it off to someone else. There are some basic precautions I told you, so you need to wait. This that I just did is not really private because I just deposited the funds and send it off right away to someone else. The ideal thing is to wait for some time, for a couple of hours, couple of days, maybe depending on the level of privacy that you want. Because the more time you give between the deposit and the withdrawal, the harder it is to actually go into the ledger and figure out who sent the money to who. So this is kind of the basic setup. Rafa, Shot, do you have any questions up until now? I feel like I'm talking by myself. I don't know if I'm going too fast.
Yeah, and just going off of that point, from what I've heard for people who have used Hideyour.cash, not saying I have, but like and they would actually let you know like how many people are in the pool. You would have to wait for that to essentially like get bigger. The bigger the pot, less likely it is you there. So this works best when more people are using it. That's why I wanted to drive awareness, and I wanted to know whether that would be like whether it would have a similar UI of like how many people are in the pool, the types of pools, or like is that something that's going to be integrated?
Yeah, for sure. This is a very good point, Shot. So essentially, this .NET version doesn't have it yet because this was a quick MVP we put up to show the functionality. We have mostly been involved in developing the concrete on the back end. It was very hard from the beginning because of the ZK tech. But right now we're going to start focusing on the front end. It's going to include like all the stats regarding how many people are in the pool, the volumes of the pool, and the volumes into each of the different deposit types, whether you want to use a relayer or not, which relayer to use. So this is all going to be integrated pretty soon into the app too. So, but you're right. One of the main concerns is that this only works if a lot of people are using it. A lot not, but a decent amount of people. And so raising awareness and actually incentivizing people to use the app is one of the first missions we're going to have heading to mainnet, is actually find ways to incentivize people and talk to the Near Foundation and to all the collectives on here to actually push the product and show everyone why this is important and how to use it, because this is the only way that's going to have a private app on here that actually works. The network still has a relatively low volume of transactions, so it's important that the most people that you can find actually use this and make privacy possible.
And yeah, and this
another question.
I would love to see this like baked into the culture of like, I don't know if it was Bitcoin Cash, but they have like Mixer Fridays where everyone comes in and mixes their coins. That would be really cool if we did that within the Near ecosystem and really made this part of our hygiene. Because I think before I kind of raise these comments, a lot of questions I have after. Word, if no one has questions, can we kind of, you mentioned like an SDK and putting this on the back end. Would love to start looking into that on this in the audience.
Oh, for sure. So yeah, essentially, Shad, what you just said, it's something that we really strongly believe into as well. So we believe everyone should be using this, even if they don't feel like they're being watched, if they don't feel like they need privacy. It's as important as this lock into your browser. If you see that site doesn't have the lock, it always shows like a warning message and people are cautious about using it. While in fact, this is not very, very dangerous. Like most sites, if you don't like pay anything with your credit card, if you don't have the lock here, it's not really that dangerous. But people are aware of this, the importance, because the browser shows it to you. And I really feel like if the community starts pushing the importance of privacy and showing warnings when people are not doing the proper hygiene with mixers, I really feel like people can start using this more and becoming an integral part of using blockchain and being a responsible blockchain user. So yeah, I really feel like this could be the future for near. Looking into some of the
Yeah, and that's part of the thing too. Like people, again, like people are always putting this bad actor thing, but that should be part of the onboarding process. And one of the things that I do is I make people make like burner wallets, use it for like one-time transactions, not and then also I also like highly encourage, like one thing that we used to do with our friends is we used to pocket check them. If they sent us a transaction, we basically see who they sent money to. We put on, like, especially in the Ethereum ecosystem, we put on alerts. So imagine your friends checking every time you get money, and it's not about whether you're a criminal or not. It's to like you guys, that's just uncomfortable. And that's part of the onboarding process. Like I can see how much money you have, I can see where it went, I can audit it, add some privacy to that. So I just want to, like, again, like this is not for criminals. This is just like how to prevent people from checking what's in your pocket.
Exactly. Yeah, it's about protecting for. Go ahead, Cameron, please.
Hey, sorry. Thanks for this is really great stuff. But is there any, the developers for all the other mixers out there, they all got arrested or put in jail or detained and stuff like that. Is there no, I mean, are you guys not scared about this, or I don't know?
Well, we have sought legal counseling regarding the matter. And in fact, when we talk about Tornado.cash, there was one arrest that happened in Europe. And the truth is that the developer was actually a KGB agent in Holland. So it was.
Oh, is that the deal? Is that why?
Yeah.
Okay.
We got Tornado.cash, because Tornado.cash is at the app too. The other mixers, they were not smart contracts. So if you look at like Blender and other mixing services, they were actually
Blender,
they were like real services that were being operated by people that were mixing the funds, which is illegal in a lot of jurisdictions.
So Tornado.cash was run by a freaking KGB guy.
Not really.
That's why they arrested him.
Yeah, but actually, the dev that was arrested was not one of the leaders. It was like a regular developer in the application.
Yeah, well,
that's also involved.
That's even more worse, I think. Why should he be arrested?
Yeah, and this guy was actively helping North Korean hackers to launder their money through Tornado.cash. So this is why he was arrested, not for building the mixer, but
that's
like
a
for
different
committing
story.
a crime. Yeah.
So Blunder's okay and the rest are okay. It's just the fact that they were actually trying to enable illegal activity. That's why.
Yeah, exactly. Okay. And our whole idea here is also, we're not rushing mainnet because of this. So we're not really interested in like rushing the app. We're getting legal counsel, and we're trying to work with authorities, so counseling with people involved in policy making, especially in Europe, and we're trying to build something that's actually like suitable, because we really don't want people to use this for crime. I mean, this is the entire reason that this app exists. So I really don't feel that way. But it's
sorry for the stupid question I had to ask,
No, it's a great question, actually. It's a great question.
That's what I asked when I invited them on. I'm like, we can completely obstruct anything. This could be like a no KYC type of deal. But yeah, they've been very transparent and open thus far. And that's the point I want to like go into later about like decentralized front ends, the SDK, how other people can incorporate this as well. Because I think part of the, outside of all the KGB stuff, one of the main arguments for that was you consentedly put up a front end and allowing for that infrastructure to continue on, so that there is no kind of central point of failure, central point of access is I want to elaborate on. But yeah, continue.
Yeah, sounds good. Thank you for that. Where are you guys based out of, by the way? I actually I see Joanna all the time in New York City at the Empire now, but I'm in New York City myself.
We're actually based in Brazil, so
Brazil?
southern Brazil. Yeah.
Okay. Very good. Thank you.
Yeah.
I was gonna say, if you're here in New York, I host the community meetups here in New York City. So you
Oh,
guys
it's awesome.
drop by. We're having raffles today. Actually, you know what?
Awesome.
I'm having a raffle today. You don't even have to be there. We're giving away free H-bar. If you guys want, I'll send you the link right now into the chat room.
Yeah, awesome.
That's great.
That's right. You don't have to be there.
I like to keep the topic on Hideyour.cash if possible.
Yeah. Sorry.
So, yeah. But we'll be in the US next year, and we'll surely drop by. But let's get back to the workshop.
So I would love to I guess learn a little bit more on how you guys plan to grow in the Near ecosystem. What type of integrations would be most helpful? What type of support would you like from just the greater ecosystem to help push forward?
Yeah,
for sure.
Let's go on faster because they have an SDK people can build on that I want to show from a developer standpoint. So
Perfect. That is exactly what I was getting at. Thank you, Shot.
Awesome. Yeah, so there are two different points at this point, because we have the SDKs and we have integrations planned. The SDKs we have at this point are more focused on building ZK stuff, not exactly integrating Hideyour.cash yet. And the integrations we are planning on building are mostly for wallets, so that you can actually do like encrypted private transactions straight from your wallet without having to go over this front end I just showed you, so that normal people can use it without worrying about how to do it. And also integrations for other apps, especially for DeFi apps. We've been seeing a lot of pressure from regulators for websites such as Uniswap or other DeFi apps, Curve, to integrate some compliance solutions into their front ends. So they're actually analyzing wallets and blocking transactions from their front ends. But we all know that this is kind of a bullshit solution, because anyone that's actually independent can just go into the blockchain by code and do all the transactions from there. So what they're trying to build is an integration that allows the apps to, at the same time, build privacy into their usage, so that they can show that whichever transaction you make with the app is going to be hidden behind Hideyour.cash, but also showing regulators that you are pushing forward compliance by integrating the solution that only allows people with their allow list permissions to use the app, so that actually analyzes if people have been involved in criminal activity, which is essentially what chain analysis and other firms do off-chain, which is going to be done on-chain, and is going to stop illegitimate actors from using the apps. So this is basically the goal. So talking about SDKs right now, we have 3 packages that we published to create.io. So they are Rust packages for developing smart contracts. One of them is a simple one. This is near BigInt. It's just a utility we built. So whenever we deal in blockchain, we're always dealing with big numbers, because Near has like 24 decimals, and inside blockchain we don't do decimals. We just deal with whole numbers. So this makes math really hard, because we can have some integer overflowing and other problems. So this is kind of a wrapper around a different library, which is uint. So it helps you use big integers into Near. So those are serializable. You can store them into contracts. You can store them into global state. You can use them inside of development. And it has a very friendly interface for Near. So it has some pretty simple methods to declare them, and can actually use them into the contracts and into collections too. So that makes it really easy. The previous approach was a little different. If you look at some very famous contracts like Finance, for instance, they do need big integer math, but they have to walk around this, because the library that they're using can't really save the values to the contract. So this is an utility method that we built. It's not really that important, but it's helpful for developers, and we hope people find this and use it. But this is more like Subtopic, the main one is this one. So this is the near graph 16 verifier. What this is that this is a implementation of ZK on Near. So essentially you can build your ZK circuit using one of the most used libraries out there, which is MinorityJS. For those that don't know MinorityJS and Circle, they are a very easy to use library built for Ethereum and EVM chains. So essentially there's a very simple getting started guide here that shows you how to build a ZK app in like, I'd say half an hour. So you can actually build this. And if you look at it at the end, they actually export this to EVM contracts. So this tutorial actually shows you how to build an Ethereum smart contract. Over here, it can just export a Solidity version of the code, but that only works in Ethereum. And this piece of code is actually very hard to implement. It's not a simple thing. It uses a lot of low-level features and requires a lot of chain knowledge. And most apps built to use this are built by people that don't actually know how to implement this. So this is it's a barrier for people to actually build ZK apps. And what we built here, essentially this library here is a way to use the same verifier into your ZK application. So you can just, as you can see, I don't know if everyone here is a developer, but you can just import the verifier struct here, and you can use it inside of your contract. So you have to initialize it with some variables. You can see into the library, there are a lot of hash values. So it's about 10 different values that generate from your ZK secret. You input them here, and after you have input them here, this library will essentially do the verification if a proof is valid or not. So you can just generate your proofs off-chain using the MinorityJS and Circle libraries, and they can be verified into Near. So this allows us to essentially build any kind of application that uses ZK on Near at this point, which was pretty hard by the time we built this. We actually built this for the NearCon hackathon, and it has been very useful since then. A lot of people have reached out looking to use the SDK. So it's a very cool application. And we also built a hash function. So we're not talking about integration ZK. MIMC is a function that's used a lot for building circuits. So we also built this into Near so that people can use it without any hassle. It's the function that is used within Hideyour.cash. It's the function that is used within Zcash as well. So we also built it for Near, and we use it into Hideyour.cash as well. So these are kind of the libraries that we built this far. Essentially, we are helping anyone that wants to implement ZK into Near to do so. This is what you have at this point. In terms of SDKs, the next milestone in terms of SDKs is an actual integration SDK for the apps to integrate our contracts and our verifiers straight into their application, so that they can work from the front end and actually make all transactions go through Hideyour.cash before reaching the final destination. This is something that's in the working at this point. Again, anyone have any questions? I don't know if anyone here is a developer. Go ahead. I think Cameron raised his hand.
Oh, I was just clapping, but
yeah.
That's a clapping emoji. Yes, like I think kind of what you were getting at, like the best partners for you would primarily be like wallets directly, or DeFi apps.
Exactly.
Have you connected to these teams already? Are you familiar with the various builder groups that we currently run?
So we have made some connections from NearCon, but we aren't connected with any groups. I think, Rafa, do you have any of those connections like on Telegram?
Yeah, we haven't started any conversation to integrate it yet at any of the apps, since we're focused on going to testnet first and probably mainnet. So, but if you have any,
we got you. We got you on all fronts in terms of intros for sure and usage, definitely. There's a big wallet selector transition happening right now. So and then Cameron posted a link. I also got all the links to all these crates packages, and I'll make it available in the video section. Do you have anything more to show in terms of like developer docs or contracts or anything like that? I see you have a GitHub in a tab. We got a Hydra tab going on over there.
Yes, we have also made this repo public. So this is kind of our main repo. It's a mono repo, so there's a lot of stuff going on. I don't know if you should like go over all of this in the workshop here, but essentially just showing everyone. You can read about how the app works in here, see how to install and run your version. But the most interesting thing is if you go into packages and contracts, you can actually see the main Hideyour.cash contract here. So I don't think this is the place to go over how it works and everything else, but you can essentially see it here and see its main methods. And essentially what this is right now is adaptable to use any kind of data provider. So we can pull data for the allow list and deny list from any source that we want, including some off-chain sources over a bridge, over an oracle. So this is kind of the overall thing, but the contract is long. There's a lot of tests and a lot of stuff going on. I don't think we should go over this, but you can also take a look at the other part of the package here, which is the circuits, which is kind of the off-chain way that the app works. This is how the ZK logic works for those who are familiar with it. It is an improvement on top of some previous Merkle tree commitment schemes that use an allow list to deny transactions. So it's also pretty interesting. And if anyone wants to go over these things more in depth, I'll share my Telegram and my Discord link, and we can set up a group chat, and I can explain how it works and show you guys more in depth as well. Do you guys want to see anything else about the code? I don't know if you should show it here. I don't know the depthness that we want regarding to tech. What do you think, Sean?
Yeah, I mean, just in case GitHub takes it down, I'll you got the YouTube reference in the video, so as much code as possible. And also, yeah, I'll make the links available. I'm out here typing URLs.
Yep.
Yeah, but definitely go into like the Snark component and a little bit about that as well. And for those who don't know, found out about this in the ZK private, the Zero Knowledge Working Group as part of the build groups. That's also in the link I'll provide. And there's also a privacy group as well. So there's been a lot of ZK development going on in the space. But I would love for you to go kind of deeper in for those who kind of want to understand. And then particularly I wanted to know kind of like a little bit of back to the contract in terms of like the ZK starts, but also like the whitelist and the approval as well.
Okay, awesome. Let's check it out.
You did make a good point about maybe GitHub would take it down, right? You never know. Like
there's always radical and decentralized front ends and a bunch of alternatives, but yeah. Just know, American government, I got this on my local computers and backed up, and I got a dead man switch.
Awesome to hear that. Yeah, we also have copies of the code. If that gets taken down, we're gonna publish it in other places too. Make some open groups. Even Tornado.cash is back on GitHub. I don't know if you saw it. There's like a Tornado.cash community account that's essentially just like maintain the code, not the service, so they can't be taken down under American law.
Yeah, and you can still interface with so I've heard with the contracts using different mirrors and then going around non-OFAC client validators as well. So I've heard.
Yeah, it's possible. It's not as easy as it was before, but it's possible. And the thing is, if you're a criminal, it's super easy. Like if you really want to use it, they're just making it harder for the regular person to use it. That's the problem. So just look at the code here. Let me get you over here. So that is essentially the main structure of the contract. Right now there's an owner that can build new pools instead of guardians. These are accounts that can blacklist people. So they are essentially accounts that are going to be set up as our bots. In the future, this is going to be transitioned to a staking schema. So essentially, when people who want to validate transaction on the protocol to stake assets and risk losing them in case they do something wrong. But for the MVP purposes, it was built as a simple list of guardians. And the authorizer is the is the contract that we pull data from. So our data source essentially, it's happy one for near at this point. Then we have commitments, and commitments are essentially a Merkle tree of all of those codes that I showed you guys on the demo. These codes that you generate, essentially you take a hash from those codes and you store them here. Then you use this Merkle tree later to withdraw those values. So, and at the same point, there is a Merkle tree called the whitelist Merkle tree. And whenever someone is whitelisted to use the application, we changed it to allow list actually, but I forgot to change the name into the code. Whenever someone is allowed to use the app, they are inserted into this Merkle tree. And again, now this is going to be a little technical for people that understand ZK, but essentially to withdraw the assets, you have to prove that both your commitment, so the key that you copied from the front end, is into this Merkle tree here, and that the account that originally deposited the funds is into the Merkle tree here. And if you ever get blacklisted, what happens is your account gets removed from the whitelist, and it cannot be inserted back unless the owner overrides it. So it becomes impossible to actually build a ZK proof that shows that you know a commitment that is into this tree, and that the user that made the commitment is into this tree here, because the user is not in here anymore. And that's why the funds get locked forever, because the proof that you need to withdraw the funds cannot be built anymore. That's how it works. And deposit value here is, this is a simple contract. So essentially it only supports a standard deposit amount. So these ones, the original one we built was for 10 years, but it can be built for any amount of year. So it's essentially how much you have to deposit and withdraw each time. Verifier comes from the library I showed you guys, so from the DearGraph16 verifier. This is a struct that stores a lot of data about the secret on initialization, and then can then verify if a proof is valid or not. And we have a nullifier list, so I look up set here, which is a history of all the proofs, so all the codes that were already withdrawn, so that no one can withdraw in duplicity. A lot of storage keys. And so when you initialize the contract, essentially you pass in those parameters. So we pass in, this is a little technical, but the height of the Merkle tree that you're using, how many of the last Merkle tree roots you're storing. So the more roots you store here, the more users you can have in the app simultaneously, because if you build proofs one next to the other, they're going to be able to, everyone's going to be able to withdraw without generating errors, but it makes it a little more gas intensive. This field size and zero value are some very technical ZK parameters as well. When you build your secret, you choose those values and you have to include them here. Height of Merkle tree again. You choose the deposit value and you pass in all the variables from the ZK secret to actually build the verifier. So to actually initialize this contract, you need to understand a lot about how a ZK secret works. So for people that are adventuring into this world and want to understand the contract, I really highly recommend you guys to first look into the Circle library here, understand how it works, understand how to build your sample project here. And then after you read this, you're going to be able to get this code and actually understand what all those parameters are. And also take a look into the secret package we have back into the repo, because it shows how our specific implementation of a ZK secret is done. So it's going to be easier to understand everything. So essentially, you can initialize the contract, and there are some calls that you can make to it. Those are just tests. Let me show the calls that you can make to the contract, because it's essentially, it's pretty simple. So there are transactions, or at least some blacklists here. On the transaction side, you can deposit and you can withdraw. So you deposit by sending over near with your secret hash. All that it does is that it combines your secret hash with a hash of your account, of the account that is deposited, asserts that the account is in the whitelist, and commits the hash to the Merkle tree. So essentially, it takes your initial proof, but it also takes the address of the person that deposited. And that's how we track after, when someone tries to withdraw the assets, if this initial account is or not into the Merkle tree. So that's how this part is done. And on the withdraw part, essentially, you send all the part. You have to send the root of the Merkle tree at the moment you're building the proof, the nullifier hash from your proof, the account that is receiving the funds, which relayer you're using. This is an option because you can also not pass a relayer. The fee that you're paying the relayer, how much you're refunding the relayer for gas, the root of the whitelist Merkle tree, and the ZK proof. Why? So essentially, all the information here is included into the proof. So when you generate a proof and you send it over into the blockchain, even if someone sees your proof, they cannot use it to steal assets from you because your proof is only valid with the root, hash, recipient, and fees that you send. So it's impossible to front run this transaction. If someone front runs it, they're only gonna be paying the gas for you, and you're gonna be getting the assets for yourself anyway. This is kind of the logic here. So it makes a lot of assertions. So it asserts that the nullifier hash has not been used yet. It asserts that the fee is smaller than the amount. It asserts that the root that we informed here is still valid. So it's one of the last roots into the system. And it asserts the same thing for the whitelist. So after it asserts all of those, it essentially verifies the entire transaction. So it applies the verifier function verify with all the inputs. And if this returns true, it's because the proof is valid. So it just runs over the code. If it's false, it's not going to release the funds because the proof is invalid. After it's been validated, essentially just insert the nullifier into the nullifier list so that no one can use the same code to withdraw anymore, emit an event, and generate a transfer of the assets to the recipient. This is how it works. So it's pretty simple on this side. And on the side of the whitelist, this is where it's still a little simpler at this point because we are still integrating with the Happy One partner. So this is a generic implementation of the contract that doesn't really fetch the data into the partner. So what it does is send over an account ID. You're going to check if the person that sent this transaction is an authorizer. So this is going to be done as a callback from the authorizer right now, but we can also change this into a couple of different ways. It's going to take the hash and insert it into the whitelist. But this is a very naive implementation. What's actually going to be happening here is anyone's going to be able to call this function on the Happy One implementation. So this part is going to go. And what it's going to do is it's going to take the account ID it sent, pass it through the Happy One data provider, and then the Happy One contract is going to return a promise to the contract here that only the Happy One contract is going to be able to call with the security score of the user. If it's above the threshold, the user is not going to be accepted. If it's below it, he's going to be whitelisted. So this is essentially how this first part works, and how it's going to work after we have the integration ready. And on the blacklist part of things, essentially it's going to be a similar situation. Right now it's implemented as a guardian that can blacklist people, but in the future, we actually want anyone to be able to blacklist people, so no guardian setup. What's going to happen here is you're going to inform an account that you want to blacklist. The account is going to be queried into the Happy One system. If their scores above the threshold, they're going to be blacklisted. If not, they're going to be whitelisted. But the entire blacklist thing is just calling the add to blacklist into the whitelist struct. And what this does is it removes the account from the Merkle tree, exchanges for the zero value, and adds it to a permanent blacklist lookup map. And in case if he ever tries to get whitelisted again, he's going to stumble into this and not going to be able to be whitelisted unless he submits a proof to the DAO that he's actually a non-malicious user. Then you can call the remove blacklist function here on his behalf. This is going to be private to the DAO. Only the DAO is going to be able to use this function. But yeah, this is essentially how the app works. A lot of technical stuff here. Still some stuff to be implemented, but this is the overall workings. Can I answer any questions or talk about some of those points? I feel like I just rushed over everything.
No, I think that was the only time anyone's gone through a Mixer code base. So I'm highly appreciative of that. I have more kind of general high level overview questions about kind of outside like the road to main that we spoke about that, but more about like feature integrations and kind of ideas I've been talking about with people in the ZK group. Mostly yeah. So I mean, Near has a unique like account model where you can you can change and rotate private keys, you can delete accounts, you can
Yeah.
have you like there's been also a lot like a surge of like name account marketplaces, whether it's like
Yeah.
GoNear, Nomen Market was one, Name Sky just came out, Spaceports just came out. So do you see like a combination of being able to swap wallets with the transaction history and also mixers outside of kind of like the Tornado Cash implementation with like a permissioning system to a more kind of native near like leveraging the account model type of mixer?
Okay, so I think there's a lot of implications on the security of this based on the way that Near works. So your question is essentially you're trying to figure out how to leverage the marketplaces and this model to increase privacy, right?
Well, not. I was just kind of using the marketplace as an example of the ability to transfer
Okay.
accounts completely and securely, rotate private keys. But I'm more talking about like, is there a model where maybe you delete an account after you use it and it automatically transfers to a new account, or you have not only mixing of transactions, but mixing of wallets where people basically give their wallet and they swap it out that way. So I was thinking of more of like leveraging that.
Awesome. Awesome. This is actually something I had never thought about. So mixing wallets, maybe this is something that works because essentially all I have to do is swap private keys, and we could delegate this to a conflict. I'm actually gonna this is something I'm gonna be looking over the weekend because it sounds fun. But yeah, it seems totally possible to me that people like commit their wallets. So like let's say 10 different people commit their wallets to the conflict, and those 10 people send over a new key, so a new public key, and the contract readily assigns one of the keys for each of the accounts. So at the end of the transaction, no one knows which account belongs to whom. So that is a way to actually mix assets that works. Actually, pretty interesting concept. We're surely going to look into it. Sorry, go ahead.
Yeah, and there's some I've been sliding the DMs in the ZK chat and kind of floating this concept, seeing who could who would necessarily run with it. So I'll link you with people who may have some specs regarding that. One thing I also wanted to get more insight on was like the whitelisting and the guardians. You mentioned it being like a bot, but is there any and in the staking system, is there any consideration in towards like a DAO in combination with the staking system? Or okay, can you explain that?
Yeah, for sure. Sorry, this is something we totally rushed over. But essentially, the idea is to have self-governance on the app. We're not going to be running it ourselves. We're surely going to for in the start, but the idea is that the app takes over the format of a DAO that is managed by the Near community. And why is that? Because there's a lot of specificities into how this works. So which kind of crimes do you want to prohibit into Hideyour.cash is it sounds like a simple question, but it's actually very hard because we're usually thinking about like US and Europe regulations. So like generally regulations from democratic countries that are generally accepted to be normal. But let's say, for instance, that we're talking about one country that has a law against free press. And so people are using the app to pay journalists. Is that something you want to block? So this kind of decisions that I don't feel like they can be made by us, by like one person alone. I really feel like it's better if they are handled over to a community, because otherwise we're going to have no control of which regulations to follow, who has to follow them. And as a DAO, a totally decentralized entity, it's easier to like have governance decide those questions and have it as a less personal matter. So I think this is very important for the organization to be entirely independent and for the app to run by itself without the need of anyone supporting it. That being said, it's all a transition process. The idea of staking before is we probably implemented a simple staking schema before we even did like a formal DAO with all of those responsibilities, because building a DAO requires a lot of engaged people and an actual thriving ecosystem. Most of the DAOs we see out there aren't really DAOs; they're totally controlled by the project founders, and this is not the goal here. The goal here is to actually decentralize decision making and to make it an app that stands for itself and that is unstoppable. So in that regard, the first step would be to bring over tokens and bring over staking as a way to participate into the activities of the protocol before we can build up to become a full-fledged DAO. So when you talk about staking, the entire idea is that we need people to run some of those bots to make the system work. Essentially, they need to be running bots to look into transactions into the protocol and see if the people that are interacting with the protocol are actually ill-intended or well-intended people based on the data that we have available. And this takes someone querying data off-chain, this takes servers working, and it's essential that this is decentralized. We can run by ourselves, so HackerChain can run those servers at first to have it done, but then the application is stoppable. It's not really Web3, it's just like a simple app. So we want to have this decentralized, and to decentralize it, the best way to do it at first is to incentivize it economically. So with token staking is a good way to do it, because people would have to acquire property and put it at risk to operate the service. If they ever went against their directions or did something wrong, we could slash their stakes. And at the same time, we could reward them with transaction fees for everything that they validate. So this is the kind of the way this would work at first. And probably the people that start doing this, start making money from it and start interacting with the protocol this way are probably going to be the first people that are going to engage into actually forming a DAO and actually becoming decision makers in the protocol into the future. This is kind of the roadmap that we envision for this. The overall idea behind staking is someone needs to be checking all the time whether the people that deposit assets have been involved in criminal activity after the initial deposit. And if they ever find that someone has been, they have to submit a proof of that over HappyOne and to the protocol. And if they are successful, they're going to be rewarded for it. And this is kind of the way. And if they try to make a wrong play, if they're trying to maliciously use the system, they're going to have their stakes slashed. This is basically the idea behind it. No, did I answer your question actually?
Yeah, no, it definitely does. They're definitely, because people always like to bring in, hey, why don't we do a DAO to administer this? And it is hard to maintain a DAO. This has been kind of even questions within a functioning DAOs within the Near ecosystem. Yeah, so I wanted to just kind of because there is a KYC DAO coming out. I don't think they have a DAO structure as well. But just to like explore on that idea. I also wanted kind of your opinions on well, firstly, like what we're doing in the Near ecosystem is we're doing a lot of like tangential KYCing. So we're building like a social, like Near Social's decentralized front ends, which builds on top of this. But at the same time, we're building a social database that's directly linking to social media accounts. There are things like Lens protocol. There's soulbound tokens. What are your kind of opinions on this? And yeah, just like kind of how the social mapping of wallets are taking place and how that relates to privacy, and maybe how Hideyour.cash can combat this.
Yeah, so this is a very hard issue. So when I talk about KYC and proof of humanity, all those concepts are very hard to do 100% on chain. So they always require linking some personal information, even if it's social media or actual document or something like that off chain, and having someone verify that the person has done the KYC on chain. And the problem with this is there's always going to be some database somewhere or where this information is available, even if for a brief period of time. And it is always possible that the people are spying on this, that people are getting this data and using it for something else. So there are 2 points here. The first point is, how paranoid are you about your privacy? If you're using a reputable firm with a great tech and everything else, the risk is reduced. you're trusting a centralized entity. So let's say you're trusting the verifier firm that's doing the QAC for you, that they're going to be holding the data carefully and deleting and anonymizing it after they don't need it anymore, according to the GDPR rules. But this is not a guarantee. They can always be doing something different. The data can always be at risk because of mismanagement and everything else. So this information is always going to be at risk somehow in there. And the ideal scenario for us is that has always been selective disclosure. So ways to actually generate ZK proofs that prove that you have done some kind of QAC without revealing any information and without having any of that information stored anywhere. This is the best way to do it. And it's also possible to do it with social graphs. So for linking social media, for instance, it's possible to do the calculations to find out whether you're legitimate and just build a ZK proof of that and delete all the data afterwards. This is all possible. And it's, in our opinion, the preferred solution to actually do like a selective disclosure for whatever we're doing. But it all comes down in the end to the off-chain player, because these calculations and this proof is not done on-chain, it's always done off-chain, and it's important that the players involved do their hygiene there. Like Hideyour.cash is a tool for on-chain transactions to become anonymous. It's not a tool for people to become anonymous off-chain. When you do a QAC off-chain, there are a lot of factors. So essentially, your internet connection can be monitored. The service that you're using for the QAC can be copying your data and can be saving it someone else, not deleting it. There might be some malware into your PC that's actually reading the data. So you have to be as careful as possible with all of those points to actually achieve privacy when doing this kind of thing. But once it goes on-chain through a selective disclosure schema or through a simple authorization of wallets list, then it's done. So after that, you're basically secure. And it also comes down to some of the requirements of the QAC. If you want a QAC like a specific wallet, one per person, you're probably going to need a ZK scheme to make sure that the same QAC is not used twice, even though you don't know, like you don't have the original information from the user anymore because you deleted it. So there's a lot of ZK tech that can be involved in there, but it really depends on the use case.
Yeah, and that's something I also wanted to ask about, because there is a ZK working group, and there's so many, like you're saying, there's so many vulnerabilities, whether it's the RPCs. I know like there's Hopper, there's Pocket, there's a lot of stuff coming from different ecosystems. So for people who are like ZK researchers and are looking at this like, hey, okay, Near got some ZK stuff going on. Like, what are you like? You mentioned like ZK snarks for this. What are you bullish on in terms of the ZK? In terms of zero knowledge in general, and what would you like to see more of in the general Web3 ecosystem in research or like coming onto Near?
Okay, yeah, so I think there are two angles on this. One angle is like tech. So we talk about ZK snark. ZK snark is essentially a ZK algorithm. There are a lot of new ones, a lot of better ones actually. So ZK snark is still one of the best ones in terms of UX. But there are a lot of new schemes that don't require a trusted setup, which is a good point. I usually prefer tech that leaves the least points of failure as possible. So and the initial setup is a point of failure for ZK snarks at this point, but also ZK snarks is still the fastest algorithm that we have for generating proofs and calculating everything, which makes for a better user experience overall. So when you talk about the rough cryptography tech on this, I would like to see more schemas that don't require a trusted setup, but I would also like to see like better algorithms for building proofs and calculating everything that allows us to build faster apps. As you saw on the app there, we're still it was very fast to calculate this proof because the app was still in testnet. But once it goes into mainnet, the time to calculate a proof is always going to be increasing. So it's important for people to have better algorithms. I think this is one of the main goals into academia and into like the more deep tech area. But I'm more excited about product at this point. I mean, I always feel like cryptography is a science that generates very few products because they are very back end and not faced other final user. People don't understand them. So I really feel like product innovation is the most important here. And like the private transaction as we are doing is one point that has been explored more. But I'd love to see more KYC and identity stuff. So especially with the considerations we just made here, like how can we reduce the points of failure into KYC, into proof of humanity, into proof of whatever it is that you need. So how can we actually integrate those with useful projects for like credit scores, for like proof of citizenship and public services and other stuff like that. I feel like that can be a great area of research there. It's also pretty interesting to look at the ways that you can use ZK to improve scalability of the blockchain, which has been doing a lot. It's been done a lot on the Ethereum network. So essentially, you can use ZK to scale the computing power of the network to require less computing operations, but you're still running short when it comes to compressing data. So theoretically, you could use ZK snarks to increase the throughput of a network by an almost infinite amount. But since we cannot do the same thing to the data that we have to store with each new transaction. That's what holds us back from scaling networks to a way more mass adoption level. And this is probably some of the things that people have to work on. It's not really specifically ZK tech, but it's how it relates to ZK products. And those are the main ZK products that I see right now. So it's privacy transactions, private identity and selective disclosure, and rollups, so scalability. And these are the three main issues in my view. So in transactions is the one we are solving, how to be compliant with legislation and provide privacy. In terms of KYC, it's how to reduce points of failure and allow selective disclosure without needing any centralized players. And on the rollups section is how to actually scale data. Because we can scale computation pretty well, but you can scale data that well up to this point.
Yeah, no, that's very insightful. I'm actually yeah, like Cameron left to a meeting that actually I was supposed to be at, so kind of want to wrap this up. But I was very interested in all of this. One of the things I see, there are a lot of points for contact. There is the GitHub. I'll make available in the video description where you can do an issue. There is also a feedback button as well. Can you kind of show different ways to contact and contribute, or like where the main kind of call to action outside of like using the application on testnet and getting on the allow list, like how else can people help and contribute?
For sure. So we're very active on the ZK group we're talking about, Shot. So we have a ZK working group on here that we were one of the first people to start it. And if you want to contribute on a technical level, this is the place to be. So we'll be posting our telegrams here so you can get in touch with us and we can include in the group and have a chat there. We'll be sending them over to you after the record is over, so you can post it. And so this is for more technically focused people. So get over there, talk to us, take a look at our GitHub. You can put issues here. We can talk about code, get some other implementations. We have some pretty interesting stuff in our roadmap, and we can discuss it further. On the product side, so marketing and everything else, I think Rafa can give a better talk than I can. But we're also starting to build up for the mainnet launch and to build up our team. So if you want to contribute, if you want to be a part of it, there might be a place for you pretty soon to the team. You want to take over, Rafa?
Yeah, sure. So what is exactly, how would you like to get involved? Short.
I'm just saying, all right, so like I just want people to know, like, all right, so like, whether it's reaching out and contributing technically, whether it's from a user feedback point, I saw there is the button as well, or whether you're like a wallet watching this, or an application that wants to integrate those crates or integrate a future SDK so that transactions are private by default. So I just wanted to like just like show the touch points to reiterate.
Awesome.
Yeah. Okay. So right now we are on testnet. We have this feedback form. We don't have a formal group. Yeah. Exactly. We don't have a formal group, a formal community for Hideyour.cash yet, but like our Twitter is open. Anyone can just go there and message us. Or we have this private group that it's actually, it was funny because we created it at the same day that you guys created the ZK group. It's separate now, but I think there are a lot of the same people that are on the same groups. And well, we can interact from both these groups. We have our Telegram group chat between us. And well, basically what we are looking now is for people to give feedback on our testnet product. And in the next few months, we'll probably going to start to talk to players on here to see how can we integrate it. But I think on the next at least 3 months, we will be very focused on just correcting the bugs and doing all the development necessary to put it into mainnet. So it's more like a background work. But while we are doing that, we will be happy to participate on conversations and to have people giving feedback on the product, and maybe like we will start to slowly craft a community, but that's not our main focus right now. It's actually to put the product live. So, well, if you have any like anything you think you can contribute to us, you can just ping me and we'll be very happy to talk.
Yeah, I absolutely love that. Builders building technology that we need. Definitely in when mainnet launch, I'm gonna link you up with kind of all the projects to integrate. For sure, and make awareness out of this in terms of testnet now. So yeah, thank you so much for coming out. And yeah, I'm gonna end the recording.